In this video, we're going to talk about systems of inequalities. Now, a set of at least two inequalities is called a system of inequalities. And the graph of a system of inequalities consists of all those points that satisfy all of the inequalities in the system. Okay, so I have a system of inequalities right here. 3x plus y is less than or equal to 7, and x is less than or equal to 2y. If I want to graph this system, I'm trying to plot all the ordered pairs that make both of those inequalities true. So for the first inequality, we can rewrite this inequality as y is less than or equal to negative 3x plus 7. I just subtracted 3x from both sides. And we can rewrite this equation as y is greater than or equal to 1/2 x. Okay, divide both sides by 2, you get 1/2 x is less than or equal to y, which is the same thing as saying y is greater than or equal to 1/2 x. Okay, now if we want to graph this system of inequalities, we have to graph these two inequalities. Now, y is greater than or equal to 1/2 x. What does y equals 1/2 x look like? Notice the y-intercept would be 0. So it goes through the origin. And the slope is 1/2, meaning if you go to the right 2, you'll go up 1. Okay, if you run to the right 2, the rise will be run. And run to the right 2 more again, you rise 1, go over 2 again, rise will be 1. So this right here is y equals 1/2 x. Now if we wanted to graph y is greater than or equal to 1/2 x, we'd be shading in above this line. Now let's not shade it in just yet. Let's also graph y is less than or equal to minus 3x plus 7. If we graph y equals minus 3x plus 7, we'll go up to 1, 2, 3, 4, 5, 6, 7. Y-intercept would be 7. And the slope is negative 3, or negative 3 over 1, meaning that if you run to the right 1, you will go down 3. Okay, if you run to the right one more again, you'll go down 3, and so on. And so this line looks like this. Okay, now to shade in this graph, though, we'll be shading below the line, so we'll be shading in all this below the line. So what parts can we shade in that will make both of these true? Well, we want to shade above that first line and below the second line. We'll be shading in this region here. Okay, and all these points over here are solutions. Now, also all these points on this line and this line will be solutions, although maybe I should erase this part here and this part here because those aren't really solutions. The solutions are all these points up in here and including along these two lines, or these two rays right here. Okay, let's do another example. Oh, by the way, the shaded region above is sometimes called the feasible region, since it consists of all the points that satisfy or are feasible for every inequality in the system. Okay, let's look at another example. Graph the feasible region for this system of inequalities. Now notice I have 4 inequalities here. Okay, the first one, 2x minus 5y is less than or equal to 10. If you solve that for y, you get y is greater than or equal to 2/5 x minus 2. And the second one, if you solve that, you get y is less than or equal to minus 1/2 x plus 4. So let's graph those two. Now 2/5 x minus 2, the y-intercept would be negative 2, okay, down here. And the slope is 2/5. So if I run to the right 5, 1, 2, 3, 4, 5, I'll go up 2. Okay, run to the right 5 more, you go up 2 again. The line is going to look something like this. Okay, that is the graph of y equals 2/5 x minus 2. Now we'd really be shading above that line because we're looking for y greater than or equal to that. Okay, now the second one, y equals minus 1/2 x plus 4. The y-intercept would be 4. The slope is minus 1/2. So if you run to the right 2, you go down 1. Run to the right 2 again, go down 1 again. Right 2 again, down 1, and so on. So the graph is going to look something like this. Okay, now in that one we'd be shading below the graph. So we'd be shading in everything over in here that's above that first line I drew and below the second one. It would be over here. But also we want x to be greater than 0. Now to say x is greater than 0, the line x equals 0, that's the y-axis. So we'd be shading into the right of the y-axis. Okay, so we'd be shading in to the right of the y-axis. And y greater than or equal to 0, well, y equals 0 is the x-axis, so we'd be shading in everything above the x-axis. It turns out our region would look like this. Okay, it's above that first line, below the second line, it's to the right of the y-axis, and it's above the x-axis. So that is what the region would look like. And again, that's called the feasible region for that system. Okay, let's do one more. Graph the feasible region for this system. Negative x plus 2y is less than or equal to 6, and also x greater than or equal to 3, and y greater than or equal to 2. Well, I solved the first inequality, and I got y is less than or equal to 2/5 x plus 2. And I'm not sure if I did that right here. Let me try this. Okay, I actually did make a mistake there. I corrected it. This first negative x plus 2y is less than or equal to 6. If you solve that, you get y is less than or equal to 1/2 x plus 3. Okay, now 1/2 x plus 3, if we graph that, we get a y-intercept of 3, and the slope is 1/2. So if we go over to the right 2, we'll go up 1. Okay, let me do this in blue. If we go to the right 2, we'll go up 1. Go to the right 2 again, go up 1 again, and so on. Okay, and we can draw in that line right here. Y equals 1/2 x plus 3, and we'd be shading in below this line because y is less than that. We'd be shading below that line. Now x is greater than or equal to 3. X equals 3 is this vertical line. Okay, x equals 3, that's this line. Okay, and to shade x greater than or equal to 3, we'd be shading to the right of that line. Okay, so this is x is equal to 3. This is y is equal to 1/2 x plus 3. And y equals 2 would be a horizontal line like this. This is y equals 2. But we have to remember where we're shading. So where should we shade? Is it going to be in here? It turns out it's not going to be, because we're shading in x greater than or equal to 3. That's to the right of this vertical line. We'd be shading above this horizontal line, y equals 2, and we'd be shading below this line, y equals 1/2 x plus 3. Notice the region would be this. Okay, this is the feasible region for that system of inequalities.